1 2 1 2 1 2 1 2 1 2. Woo!
Hello guys and welcome back to this one. So we've seen the recursion, we've seen the stack, we've seen the what do we have? We've seen the what's the last bit that we did before now? We did Morris, right? We did Morris and now we are going to do the parent pointer so that we satisfy everything that the question asks for. It asks for recursion, it asks for using that we shouldn't use a stack, we shouldn't use recursion, and we shouldn't also modify the three. So we are looking to now finally make sure that we meet all these conditions as to solve the Inorder Traversal. And obviously characterized with the Inorder Traversal is the fact that all our tree comes alive in the sense of like we print everything in order. So we have 1 2 3 4 5 and we'll see that here. So starting off, we redefine our parent, our binary search tree in the sense of adding a parent pointer to it and obviously pointing it to none for the first instance. Now we redefine everything again from the top because we've changed what the BTS finally initially was defined as, and we've made it something else. So we have to create BTS parent nodes in that sense. Basically, yeah. So we also constructed them, right? We constructed them to like now have the parent pointer points to their parents as when due, right? So we get into the function now. Obviously, as we always take it, we take it from the code to the graphical illustration to the debugger tool, so that by the end of the day we harness this knowledge and we know we can call it our own. So now we're going to be looking at the code. We look at the inner transversal. We call the parent, and the parent tree, right, goes ahead to say, okay, if this node is empty, right, if it is none, if we don't have a node, right, that if the node is none or the node doesn't exist, right, we should return immediately because there's nothing to transverse on there. Now we point the node to current. Basically we call that current, and then our previous node is none for the first instance. Now we would look at the while loop, right? So we start the while loop and we say while current is not known. So we continue to transverse. Now we look at the first block. Usually we have 3 blocks and 3 instances. Basically the first instance is when we want to go left. And what do? We say if the previous is equals to current dot parent. So if the guy that we are pointing at has its previous as a current dot parent, that means obviously the current at that point would be the head node that would then spread out to the left and the right branch. So for that reason, we say if it's the left, we want to point the previous to current, right? So basically we bring it down and then we point current to the left. So we are going to the left, we're going leftward, right? And else, if that's not the case, we would print out the current value and previous we pointed to current and current. We go either to the right or go back to the current. That's if the right is a none. So if it doesn't exist, if the right is a none, we go back to the parent. If the right exists, we go to the right. So the second instance or the second block, the else if, is saying when we are coming back from the left node. So when we finish traversing the left and we're trying to come back. Now, what do? We print out the current value. So we say the first key, the case is if previous is equals to current or left, right? If previous is current or left. So if our previous is presently at the current or left, right? And we've moved on our current um to the parent head at that point. So just to make it clearer, this as we most times do, it becomes clear in the graphical illustration where we use. I believe this one even goes to the. I think the debugger session takes it where it would really crystallize what's going on, how these blocks matter. But just to like explain the code before getting there, we just say we print out that current value and then we take our prev back to current where we go back to the head and then we try to transverse the right. And then when we are coming back from the right, so if our previous was the current right, which is the L statement, which is the remaining statement, the remaining block, so we've gone from the node to the left, from the left back to the node to the parent, and now we're going from the parent to the right. We see prev equals to current and current equals to parent. And that's the block of code that we are going to be examining in the graphical illustration and the debugger tool. So stay tuned for that. See you on the next one. Muchas gracias. Bye.